All right, let's look at the first asterisk problem that we have on our worksheet. Number 4, we have if a plus b equals 90 and a equals 30, then 30 plus b equals 90. So basically you're trying to figure out what changed between the if and the then. The first part of the if statement said a plus b equals 90. The conclusion says 30 plus b equals 90. So we originally had a plus b equals 90, and then we have 30 plus b equals 90. So what has changed? Well, b's there, 90's there, stayed the same, but the a turned into a 30. The only way an a can turn into something else is if we substitute another value in for a. So we were told here that a was 30, so we replaced this a here with what it equaled, 30 here. So that is going to be our substitution property. We substituted. Okay, let's also take a look at number 6. We have if 7x equals 42, then x equals 6. And what has happened here? What changed between the if and the then? Well, the 7 went away. It's now a 1. And the 42 decreased, and it's now a 6. So the only way that can happen is if when we're solving our, using our algebraic properties to solve an equation, is we divide both sides here by 7. 7 divided by 7, that's our 1 here. And 42 divided by 7, that's our 6 here. So we have only divided using the division property of equality. All right, let's go down to number 9. And one of the reasons that I put an asterisk next to this one is because it's got a fraction in it. And a lot of you shun away from fractions. You really hate those fractions. They scare you, and then you just want to quit. But it's not that big of a deal. Whenever you see a fraction in an equation, you have to get rid of that fraction. You have to make it something that you're used to dealing with, such as whole numbers here, 2 and 10. We like those whole numbers. So how do you get rid of a fraction? Well, a fraction is simply a number divided by another number. It's division. And remember, when you're dividing, in order to undo that division, we have to do the opposite of our original operation. So in order to undo this division here, what's the opposite of multiplication? Well, what's the opposite of division? Well, I just told you, multiplication. So we have to multiply everything in this equation by 4 in order to undo this division here. So that's just a heads up of what we're getting into. Number 1, this is what our original statement said, 2x minus 10 equals 3/4 x. Why is 2x minus 10 equal to 3/4 x? Well, remember your reasoning, because it was given to us. So that's going to be a given. Okay, so down here, number 2, the 2 gets bigger. It turns into an 8. The negative 10 gets smaller, turns into negative 40. And the 3/4 is no longer a fraction. It's a whole number here. So remember, how do we get rid of that division of 4? Well, we multiply everything by 4. So let's check. 4 times 2, well, there's our 8. 4 times a negative 10, there's our negative 40. And 4 times our 3/4, remember the 4 and the 4, the numerator and the denominator, they divide to turn into 1. So we're left with 3x. So all we've done here is we've multiplied. So that's our multiplication property. Okay, now how do we get to step 3? Well, the 8x has gotten smaller. It's now 5x. The negative 40 has not changed. And the 3x is gone. So because this negative 40 here hasn't changed, that means that we haven't multiplied or divided by anything. Because up here, when you multiply or divide by anything, you have to do it to every term in the equation. Well, we didn't multiply or divide because negative 40 hasn't changed. When things get smaller or bigger, we're either dealing with the addition property or the subtraction property. So how does an 8x turn into 5x? Well, 8 minus 3x gives us 5x. And 3x minus 3x, that's our 0 here. So we have subtracted 3x from both sides of our equation. Okay, number 4. Let me erase some of this so it looks a little bit better. How does 5x minus 40 change to step 4? Well, the 5x is still there. The negative 40 is gone. And the 0 is now a positive 40. So remember, we haven't changed any values. The 5x is still a 5x. So this can't be multiplication or division. It can only be addition or subtraction. So the only way to get rid of a negative 40 on the left side of the equation and to turn a 0 into a positive 40 is if we add 40 to both sides of our equation. So we have used the addition property. And the last step. How does the 5x equals 40 change in step 5? Well, the 5x has become an x, and the 40 has become an 8. So when all of the terms in the equation have changed, it's going to either be multiplication or division. And if you remember your algebraic equation, how you solve an algebraic equation, the last step here would be to divide both sides by 5. 5 divided by 5, that's our 1x, and 40 divided by 5, that's our 8. So we've utilized the division property. Okay, and always check in the very beginning where it says what your given is. Make sure your given matches the original given here. So make sure this number 1 matches this up here given. And then, of course, make sure your number 5, or your last step, matches what you were supposed to prove. Does x equal 8? Yes, x equals 8. Okay, on to number 11. So here's our given, y plus 2 divided by 3 equals 3. Here it is right here, y plus 2 divided by 3 equals 3. So that's always going to be our given for step 1. Step 2, how does y plus 2 over 3 no longer remain as a fraction? How does it turn into just y plus 2, that numerator? And how does 3 increase to 9? Well, everything has changed. Remember, when you have division, meaning a fraction, you have to undo that division by multiplying everything in the equation by 3. So 3 times y plus 2 over 3 is y plus 2, and 3 times 3 is 9. So this is our multiplication property. And then last step, how did y plus 2 equals 9 change from step 2 to 3? Well, the y is still there, so we know we're not dealing with division or multiplication. The 2 is gone, and the 9 has decreased. So the only way a 9 can decrease is by subtraction, without the y having not changed. So we're subtracting 2 from both sides of our equation. 2 minus 2 is 0, that's why we have nothing here. 9 minus 2 is 7, so this is the subtraction property. And once again, just check to make sure that what you were trying to prove is actually what you proved down here. And the last one, number 13, we have a big, long, lengthy mumbo-jumbo equation. So first step is always to check your given and make sure it matches your given here. So we have negative 2x plus 6 minus 7, that negative 2x plus 6 minus 7. 8 has x minus 1, 8 has x minus 1. We're good. Our given is actually what we were given. So that's given for 1. For step 2, there's a lot of different ways they could have gotten from step 1 to step 2. They could have gotten rid of this 2 here. If they've gotten rid of this 2 here, it would have kind of complicated things because we had this set of parentheses here. So whenever you have a set of parentheses and you've got something outside of that set of parentheses, you're probably going to need to distribute first. So all we're doing is we're going to distribute the negative to the positive 2, so we get negative 2x, and the negative to the positive 6, so we get negative 6. The negative 7 here doesn't change. The 8 half x doesn't change. And the negative 1 doesn't change. So all we've done is distributed that negative. All right, from step 2 to 3, negative 2x minus 6 minus 7, negative 2x minus 13. So the negative 6, the negative 7, what they've done is they've combined negative 6 to negative 7. So they did negative 6 minus 7, which is like saying you owe $6. You owe $6, and you owe 7 more. Anytime you see a negative, it's like owing money. So you owe a total of 13. So that's what changed from here to here. And remember when I said earlier with the first video, whenever you actually do the math, This negative 6 minus 7 has been substituted with what it equals, which is negative 13. And this is a tricky one. It's hard to see it because you're just like, well, they just subtracted here. They didn't subtract. They just combined, where they replaced negative 6 minus 7 with what it actually equals, which is negative 13. It's the substitution property. The same thing as if I had this, 6 divided by 3. And then my next step was 2. I've replaced 6 divided by 3 with what it equals, which is 2. So that's the substitution property. All right, let's look at step 4. We have negative 2x minus 13 equals 8/2 x minus 1. In this step, we have negative 4x. So, so the negative 2 turned into negative 4. The negative 13 turned into negative 26. The 8/2, that's our trick right here. That fraction went away. Well, we have undone, or we undid, the division here. And when you undo division, that means you had to have multiplied everything in your equation by this denominator here. So we multiplied the 2 by negative 2, which is negative 4. 2 times negative 13, which is negative 26. 2 times 8/2, the 2 and the 2, numerator, denominator, they reduce to 1. So we're left with 8x. And negative 1 times positive 2 is a negative 2. So we have multiplied. All right, how do we get from step 4 to step 5? Well, the negative 4x has disappeared from the left-hand side. The negative 26 stayed the same. So one thing disappeared, one thing stayed the same. That means we're not dealing with division or multiplication. We're either dealing with addition or subtraction. The 8x has increased. That means it has increased to 12x. And the negative 2 and the negative 2 have stayed the same. So when we have increased, that means we added somewhere. So that came from this negative 4x here, undoing the subtraction of 4x by adding 4x to both sides. So this is the addition property. Okay. Whew, this is a long one. Step 5 to step 6. The negative 26 has gotten bigger. It's negative 24 now. The 12x stayed the same. So we're not dealing with multiplication or division. We're either dealing with addition or subtraction. And the negative 2 is gone. So how do we get rid of, or how do we undo that negative 2? How do we find its zero pair? Well, we would have to add 2 to turn it into 0. And here, let's look at the math here. Think about it like money. You have a negative 26. You owe $26. But someone just gave you $2, positive 2, to put towards that debt. So now you only owe $24. It's better than owing 26. But we did add using the addition property. All right, step 6 to step 7. Negative 24 is gone. It's now a negative 2. And 12x is now x. So both of those terms have gotten smaller. That means that we've either multiplied or divided. And when both terms get smaller, that means you've divided. We divided both sides by 12.